Hello student, good morning. I am Dr.A.K, Professor of Chemistry. Today I am going to discuss dis, uh, displacement reaction. In that non-metallic displacement was left out. Last class I have discussed displacement reactions, displacement redox reaction. In that metal displacement I have discussed. Now I am going to that under displacement redox reaction, non-metallic displacement. Here it is similar but it is related to non-metal, and first one what I discussed under displacement redox reaction, that was for metal displacement. Now non-metal displacement redox reaction. The non-metal displacement redox reaction include hydrogen displacement and rarely occurring reaction involving oxygen displacement. Sometimes very less time oxygen displacement will take place, but mainly there will be hydrogen displacement. Okay. All alkali metals and more alkaline earth metals like calcium, strontium and barium, these are actually alkaline earth metals. Then all alkali metals and some alkaline earth metals like calcium, strontium and barium, which are very good reductant. These are very good reductant, means reducing agent will displace hydrogen from cold water. From the cold water, H2O is there. H2O means water. Then from H2O, H2 will go and other will come. That is the displacement. This hydrogen is non-metal. Then from H2O, H will be replaced by other metal, other non-metal. Okay. Example, now I am telling you 2Na plus 2H2O. Then 2Na, Na is a solid. Then it is an elemental state. Its oxidation number is 0 plus 2H2O. Then H2O, H has plus 1 oxidation number, oxygen has minus 2. Then when both will react, 2 sodium plus 2 H2O, when it will react, it will form 2 NaOH, sodium hydroxide, plus hydrogen gas. Then hydrogen gas oxidation number will be 0 because it is in gaseous state. And sodium already it is plus 1 and oxygen minus 2. In NaOH I am talking about Na plus 1, oxygen minus 2, hydrogen plus 1. Okay. Then here in this reaction, this is a balanced equation 2Na plus 2H2O. It will form 2NOH plus H2. H2 is going to be removed. Okay. Second example you can tell calcium plus 2H2O. Calcium plus 2H2O. Then calcium oxidation number is 0 because it is in an elemental state. And in 2H2O, hydrogen it is a fixed plus 1, oxygen minus 2. And its product will be calcium hydroxide, CaOH whole 2 plus H2. H2 is again going to be removed, but H2 has oxidation number 0 because it is in gaseous state. And calcium, that is a plus 2, oxygen minus 2, hydrogen plus 1. This I told in the case of calcium hydroxide, CaOH whole 2. Calcium plus 2, oxygen -2, hydrogen +1. Less active metals such as magnesium and iron react with steam. Steam means you can say boiling water. That time whatever vapors comes, that is the steam. Steam is more dangerous than boiling water. Then less active metals such as magnesium and iron react with steam to produce dihydrogen gas, means hydrogen gas. Okay. Then magnesium plus 2H2O, balanced equation I am talking about. Magnesium is solid, hence its elemental state, oxidation number is 0. 2H2O, then here oxygen -2 and hydrogen +1. Then if both will react, means magnesium oxide plus 2H2O, when it will react, it will form magnesium hydroxide. Then here magnesium will be +2 state and oxygen same way -2 and hydrogen +1, and it will remove H2 gas. H2 will have 0 oxidation state. Then here also hydrogen is going to be replaced. And one more example I am giving you. 2Fe solid plus 3H2O. Then it will give Fe3O4. Not Fe3O4, Fe2O3. It gives Fe2O3 plus 3H2. Then here reaction is balanced equation I am talking about, 2Fe plus 3H2O. Then here again hydrogen is going to be removed, displaced. Okay. Then product is Fe2O3. Then Fe2O3, here iron has +3 oxidation state. Fe2O3, by seeing this molecular formula only you can understand it is a cross. Fe2O3, then this 3 is for Fe. Fe valency or oxidation number you can tell, and Fe2O3, then this 2 is for oxygen. And already you can calculate also, last class I told in details. Then here Fe2O3, Fe is +3, oxygen is -2, and 3H2, then 3 gas, hydrogen gas is going to be removed. It has 0 oxidation state. Then these 4 example I have given you. In all example, hydrogen is going to be displaced from water. First example I told you, sodium plus water. Actually sodium reacts violently with water. Sodium or potassium both react violently with water, and it displaces hydrogen, means 2H2O. H2O was there, in that hydrogen is there, that is going to be removed. Then all 4 second cases I told, calcium plus twice H2O, there also hydrogen has been removed, means displaced, and in the place of hydrogen OH ion came. That's why it formed 2NaOH whole 2. In the first case, 2Na plus 2H2O, 2NaOH, and calcium plus 2H2O, CaOH whole 2 plus H2. In every case, H2 is going to be displaced, and in this OH is coming. Okay, OH is coming. It is forming calcium hydroxide. Third case I told you, Mg plus 2H2O, MgOH whole 2 plus H2. Then in every cases, hydrogen is going to be displaced. Many metals including those which do not react with cold water. Many metals will not react with cold water, but capable of displacing hydrogen from acids. From acids, if hydrogen is there, then even the many metals, they can remove the hydrogen from the hydrogen from acid, because in acid like H2SO4, HCl, H1O3, these are the acid. Hydrogen is there, then it can remove the hydrogen, means displace the hydrogen. Then many metals, including those which do not react with cold water, are capable of displacing hydrogen from acids. Dihydrogen from acids may even be produced by such metals which do not react with steam. Again, here it is important things. Dihydrogen from acids may even be produced by such metals which do not react with steam, but they will remove hydrogen from acid. Cadmium and tin is such type of metal. Cadmium and tin are the examples of such metals. Okay, now I am giving few examples which can remove metal which can remove H2 from acid. Then first example, Zn plus HCl. Zn plus twice HCl. Then it will form ZnCl2 and hydrogen will be removed plus H2. Then Zn is solid and its oxidation number is 0 because it is in elemental state. And twice HCl, then HCl again, H will be plus 1, Cl will be minus 1. And it will form ZnCl2. ZnCl2, zinc chloride, aqueous solution it will form and hydrogen will be removed. Means will be displaced from HCl. Then Zn plus 2 HCl was there. Then in the place of HCl, then H is going, and in the place of H, Zn is coming. That's why it formed ZnCl2. Zn plus twice HCl, ZnCl2 plus H2. Hydrogen is going to be displaced. Other same type of reaction, magnesium plus 2 HCl, it will form MgCl2 plus H2. Okay, and iron also Fe plus 2 HCl, then FeCl2 plus H2. Then in all three reaction, H2 is going to be displaced from the acid. Acid means here HCl. Okay. Then in all reaction, I told you that hydrogen is going to be removed. Now just I have already discussed that this hydrogen gas in laboratory actually you want to prepare, then you can prepare hydrogen gas by these methods only. In a lab, hydrogen gas is made only by these methods. Here, the reactivity of metal is reflected in the rate of hydrogen gas evolution. If a gas is coming fast, it means metal is reacting fast. Okay. Reactivity of metal is reflected in the rate of hydrogen gas evolution, which is the slowest for the least active metal. Here you have to understand this rate of hydrogen gas evolution, which is the slowest for the least active metal like iron, and the fastest for the most reactive metal magnesium. With magnesium, hydrogen will evolve more fast, and with iron it will be slow. Question is asked. Okay, with iron, hydrogen will evolve slowly, but with magnesium it will be fast. Fastest you can tell. This I told you. For iron it is less. Iron is less active. That's why hydrogen gas will evolve slowly. And this and the fastest for the most reactive metal, okay, magnesium. Magnesium very, you can say, and very less active metals. I told magnesium is the fastest, very less active metals which may occur in the native state, such as silver. Silver also remove hydrogen, but very, very slowly, very slowly. Okay, silver and gold. Silver is Ag and gold is Au. Then these occur in the native state, means elemental state. Do not, even the day actually so slow, you can tell, do not react even with hydrochloric acid. It is inert gas actually, inert metal. This silver and auric is inert. It will not react with anything. That's why all jewelry, all it is used as a jewelry. Its signing will be as it is, silver and auric means gold. Because why these are used in jewelry? Because it does not react. These type of metals don't react with air, don't react with water. Hence its signing will be as it is. Okay. It reacts only with, you can say, this thing, sulfur and very active oxygen, then it can react. Otherwise, it will not react. And signing will be as it is. That's why it is used in jewelry. Okay. Now, again you can know further that zinc, copper and silver, through they have tendency to lose electrons, so their reducing activity. These Zn, copper, silver, they have tendency to lose electron. Okay, and because it is a losing electron, then loss of electron is what? Loss of electron is oxidation. Correct? And because it is losing the electron, that is the reducing agent. This is called reducing agent. Okay, that reducing metal also you can tell. Question is asked. Metal generally, all metals are reducing agent because they are losing the electron. Okay, those who will accept the electron, that will be oxidizing agent. Already I have told. Oxidizing agent is also called oxidant. Reducing agent is also called reductant. Okay. And then their tendency you can compare. Then their order is Zn is greater than copper, copper is greater than silver in reducing capacity. Means zinc ion will reduce faster than copper, and copper is faster than silver. Means it will donate electron. And this is the tendency. Zn will lose electron very fast. After that, copper will come, and third is the silver. Okay, and this I told you. In activity series, it will be arranged like that only. Now, this I have told you about their tendency to lose electrons, and that's why they are showing reducing activity. Okay, and order of, and this reducing activity is in the order of Zn is greater than copper, copper is greater than silver, like metals. Activity series also exhibit for the halogens. Halogens also you can see the in activity series. It is also there. The power of these elements as oxidizing agent decreases as we move down from fluorine to iodine in halogen in halogen group. Top is the fluorine. After that, fluorine, chlorine, bromine, iodine. Okay. Then what is the power of these elements as oxidizing agent, because they accept electron. Fluorine, chlorine, bromine, iodine, they accept electron, hence it is oxidizing agent. Okay. Then here fluorine accept electron very fast. Okay. Then I told you that the power of these elements as oxidizing agents decreases as we move down from fluorine to iodine in group 17 of the periodic table. Means fluorine will be fastest, and after that chlorine first, then chlorine, and third is bromine, fourth is iodine. Astatine is radioactive element. This question is also asked. Then this can say decreasing order. This implies that fluorine is so reactive that it can replace chlorine, bromine, and iodine. Fluoride, you can tell. It can replace fluorine because it is very, very, very high oxidizing agent. Hence, it can replace only in their groups. Chlorine, bromine, iodine is there, then it can replace the chloride ion, bromide ion, iodide ion. Cl means Cl minus, Br minus, I minus. This is the chloride, bromide, iodide. Then fluoride, because it is a highly oxidizing agent, it can replace these three also. Means it can go in the place of chloride ion, it can go in the place of bromide ion, it can go in the place of iodide ion. Okay. Then this I told you, this is a very, very important. Okay. Then fluorine is an reactive, very reactive. Fluorine is so reactive that it can replace chloride, bromide, iodide ions in solution. In fact, fluorine is so reactive that it attracts water and displaces the oxygen of water. See how much it is reactive. If fluorine and water is there, then it will remove the oxygen from water. Oxygen, H2O, O is there. Then oxygen is also electronegative. Oxygen is also electronegative. You should know. Very important question. Always it is asked in medical engineering, in general competitive exam also. Fluorine is the most electronegative element. Second position is of oxygen. Third is of nitrogen. Fourth is, you can say, chlorine, and then bromine, and then iodine. This question is asked. Okay. Oxygen is, you can say, second position. After that, nitrogen, third position. Fourth is chlorine. Fifth is bromine, and last is iodine in whole periodic table. Okay. This question is asked. Then I was telling you that fluorine, if it will react with H2O, then they will remove from H2O, they will remove O, and it will come in the place of oxygen. Means here oxygen is going to be replaced. Example I am telling you, 2H2O plus 2F2. 2H2O plus 2F2 fluorine. It will give you 4HF, hydrogen fluoride, plus oxygen. Okay. Then here oxidation state, if you write, then H2O, H is plus 1, oxygen is minus 2. 2F2, F2 fluorine gas is there, then it will be, its oxidation number will be 0, oxidation state will be 0. Okay, then here 2H2O plus 2F2, it will give 4HF. Then here H is plus 1 and F is minus 1, oxidation state I am talking about, plus oxygen it is going out, means oxygen oxidation state is, or oxidation number both are same. Then it is 0 oxidation state and it is going outside, means displacement took place. It is for this region that the displacement reactions of chlorine, bromine and iodine using fluorine are not generally carried out in aqueous solution. Here typical question they are asking, why when it can displace this chlorine, bromine and iodine, then why in water, suppose this chloride, bromide and iodide, suppose it is in water, that time fluorine can react, but what happened, because these chloride, bromide, iodides are present in water, then it will not displace chloride, bromide, iodide. Why? Because in water H2O is there, then it will displace oxygen, means fluorine will be used up in displacing the oxygen. That's why if you can say, if in pure state, if water is not there, that time it can replace chlorine, bromine, iodine, because water is not there. But if water is there and this chlorine, bromine, iodine is there in water, then it will replace oxygen, because it has, you can say, with oxygen it has more affinity, because oxygen can give the electron. Then this is the very, very important things I told you. This is actually for this region that the displacement reaction of chlorine, bromine and iodine using fluorine are not generally carried out in aqueous solution. On the other hand, chlorine can displace bromine and iodine ions in an aqueous solution, but chlorine can displace bromine and iodine in aqueous solution, but fluorine can't displace all three, chlorine, bromine, iodine, in aqueous solution, because fluorine reacts with water and they will remove oxygen present in water, means H2O. Okay, this question is asked. Okay, why fluorine can't displace chlorine, bromine and iodine in water? This question is asked. Then now another example, just you can see that I told you that chlorine can displace bromine and iodine ions in an aqueous solution. Reaction I am telling you, Cl2 plus KBr is there. Suppose reaction is going on, chlorine gas you are passing in potassium bromide solution, KBr, Cl2 plus 2 KBr, it will give 2 KCl plus bromine. Bromine is actually liquid. Okay, Br2, it exists in the form of Br2. It is also, which is existing, that is oxidation state is given 0 value, because that is just like elemental state. Br2 they are existing, then it is a liquid, then its oxidation state is 0. This question is also asked. Then here you can see Cl2 plus 2 KBr, it is giving 2KCl plus Br2. Then here you can see that this chlorine is removing, displacing bromine. Chlorine is reacting with KBr, with a K bromine is there, bromide ion is there. But now they will remove bromide ion and it will go in its place. Means it will form KCl. Then 2KBr. Then 2KBr means 2 bromide ion was there. That's why it will form Br2. And its place, both Cl2 was there. It will come here and it will form 2KCl. Then here bromine is going to be displaced by chlorine atom. Okay. Now second example again I am telling you, Cl2 plus 2Ki, potassium iodide. Then here also iodide ion will be removed. Iodide ion will be removed by or displaced by chlorine and it will form 2KCl plus I removed iodine, 2Ki was there, then 2I it will form iodine. Iodine is solid and its oxidation state is also 0. See, fluorine F2, because it is gas, due to that its oxidation state is 0. And bromine exists in the liquid form. That's why again its oxidation state is 0. And iodine is in a solid state, I2. Correct? Then all three, fluorine, chlorine, bromine, iodine, fluorine, chlorine, bromine, all four, their oxidation state is 0. This is also very, very important and interesting also. Okay. Now this I have given the example of, you can say how chlorine is removing, chlorine removed bromine and iodine. Okay. As bromine and iodine are colored, actually again I told you reddish brown, bromine is reddish brown and iodine is bluish, deep blue, violet, like violet. Okay. As bromine and iodine are colored and dissolve in carbon tetrachloride, it will dissolve, CCl4. Yeah. As bromine and iodine are colored and dissolve in carbon tetrachloride, can easily be identified from the color of the solution. Okay. Bromine displaced, how will you come to know? Because its color is reddish brown, reddish. Okay. Then it will dissolve in carbon tetrachloride and solution will turn reddish. And iodine, if iodine is coming out, it will dissolve in carbon tetrachloride and color will become violet. Okay. Then as Br2 and I2 are colored and dissolve in carbon tetrachloride, can easily be identified from the color of the solution. Then these two reaction means Cl2 plus 2KBr and Cl2 plus 2Ki. These two reaction can be identified very easily. Okay. These reactions can be written in ionic form also. These two reactions you can write in ionic form also, means Cl2 plus 2KBr. Then it will give 2Cl minus plus Br2. Okay. This also ionic form reaction. I am talking about Cl2 plus 2Br, bromide ion. Now only bromide ion is there. Suppose Cl2 and Cl2 is dissolving into the bromide ion. Then it will form 2Cl. Okay. Plus bromine. 2Br minus was there. It will convert to Br2. Bromine. And bromine, its oxidation state is 0. Just like chlorine plus 2I minus. Just like 2Br minus, here 2I minus is there. Then Cl2 plus 2I minus, it will give 2Cl minus and 2I minus will convert to I2. iodine solid. Okay, Br2 liquid and iodine is solid. And chlorine, which was gas, now it converted into chloride ion. Okay. Reactions form the basis. This I told you, ionic reaction. That reactions form the basis of identifying bromide ion and iodide ion. Okay, because they will change the color. Bromide ion, when it will convert to bromine, it will be reddish. And iodide ion, when it will turn to iodine, it will become violet or blue, deep blue. Then these reactions form the basis of identifying bromide ion and iodide ion in the laboratory through the test popularly known as layer test. This is actually called, this test means chlorine plus if bromide ion is there in the solution, then it will give red color, and if chlorine will pass and iodine is there, iodide ion is there, then it will give violet color. Then this test is called layer test. In lab, it is identified whether it is a bromine or iodine if its color is reddish. If you are passing chlorine gas and you don't know in solution chloride ion is there or bromide ion is there, bromide ion is there or iodide ion is there, you don't know, but you know that both may be. Then chlorine, if you will pass chlorine gas, then reddish, if it is giving reddish color, it means bromine is there. Okay, means bromide ion is there. And if it is giving violet color after passing chlorine gas, it means iodide ion is there. Okay, then this test is called layer test. It may not be, it may not be out of place in to mention here that bromine likewise can displace iodide also. Similarly, all are ruling fluorine can displace these things. Chlorine can displace bromine can displace iodine. Then here same reaction is there. Bromine is going to replace iodine. Bromine liquid you are putting in iodide solution. Then now bromine liquid, that will become bromide ion, 2Br minus, and 2I iodide ion was there, 2I minus, that converted it to iodine. Iodine is solid. The halogen displacement reactions have a direct industrial application. It has used in industry. The recovery of halogen from their halide requires an oxidation process, which is represented. You can represent, suppose X is in general halide ion, X minus. In generally, X minus, X is represented for halogen. Then suppose 2X ion is there, then 2X will convert to X2 plus 2 electron. That is the oxidation. They are losing the electron. That is the oxidation. 2X is there, then 2X, X minus means halogen, maybe fluoride ion, maybe chloride ion, iodide ion, bromide ion, anything. Then that two negative charge is there, 2X minus. Then minus means electron, that will come out, and 2X, that will become X2. Okay, here X denotes halogen element, whereas chemical means are available to oxidize chloride ion, bromide ion and iodide ion. It can be oxidized as fluorine. Means these things, chloride ion will be oxidized like Cl2, bromide as a Br2, I minus as a iodine. Okay, as fluorine is the strongest oxidizing agent. Okay, then fluorine can displace all three. Okay, there is no way to convert fluoride ions to fluorine. Fluorine can convert iodide ion to iodine, bromide ion to bromine, chloride ion to chlorine. Fluorine can do, but fluoride ion itself, it is very difficult to convert into fluorine. Okay, it is very difficult for fluoride ion to convert into fluorine. Just it is difficult, most difficult. The only way to achieve F2, if you want fluorine from fluoride ion, then how will you get? The only way to achieve fluorine from fluoride ion is to oxidize electrolytically. If you will oxidize fluoride ion electrolytics, I will tell you, electrolytically, only then it will convert fluoride F minus will convert to F2. Okay, this I have told you. Now next redox reaction, next type of redox reaction is disproportionation reaction. Disproportionation reaction. This is a type of redox reaction. Here I will tell you what is actually this disproportionation. Disproportionation reaction, what is this? Then here, first I will make you very easy, then I will go to somewhat details. Here what happens actually, that some element, maybe metal, any metal, maybe oxygen, hydrogen, okay, phosphorus, sulfur, chlorine, that it will convert after the reaction as a product. It will give, after reaction it will give it may give 2-3 product, and as for example phosphorus or sulfur, it will give, after the reaction it will give can say products, maybe give 2-3 product. In that phosphorus or sulfur may be there. But if you will calculate oxidation state, then you will find that now oxidation state is different. Okay, they are giving product of sulfur only, 2 products of sulfur, 3 products of sulfur, 2-3 product of, you can say these things, phosphorus they can give, but you will find that oxidation number is different. Oxidation number, or also you can tell oxidation state is different. Then this type of reaction, that is called disproportionation reaction. Okay. Then now you will understand. I am telling you, you can say I am telling details of this reaction. Disproportionation reactions are a special type of redox reaction. In a disproportionation reaction, an element in one oxidation state is simultaneously oxidized and reduced. Also you can tell, because they have different oxidation state, means they will oxidize also, they will reduce also, both they can do. Okay, that is the special things that in an element in one oxidation state is actually product. I am talking about the reactant. In a disproportionation reaction, an element in one oxidation state is simultaneously oxidized and reduced. One of the reacting substances in a disproportionation reaction always contain an element that can exist at least 3 oxidation state. See, 3 oxidation state it will have. In reactant side only one was there, but product they are giving 3 type of products, and 3 oxidation state they will have. Okay, they can exist in at least 3 oxidation states. Okay, the element in the form of reacting substances is in the intermediate oxidation state and both higher and lower oxidation state. Here again see, the element in the form of reacting substances. Suppose any element is reacting, that is the one form. The element in the form of reacting substances is in the intermediate oxidation state. That reactive substance will be in the intermediate state, and other two, then one will be higher and other will be in a lower oxidation state of that element. That is that formed as a product in the reaction. The decomposition of hydrogen peroxide is the example. The decomposition of hydrogen peroxide is a familiar example of the reaction where oxygen experiences disproportionation reaction. Two example I am telling you, 2H2O2. Then here hydrogen is +1 because it is peroxide. Then oxygen have here -1. Don't forget. Generally oxygen have oxidation state -2 in general, but in peroxide it is -1. Many times question is asked, don't forget. Then now here H2O2, 2H2O2, when it will decompose, then it will give 2H2O plus O2. Product is H2O plus oxygen gas. Then oxygen gas has 0 oxidation state, oxygen. But 2H2O, then hydrogen is +1. Hydrogen is +1, already you know. And oxygen is -2. Then now see the condition of oxygen. Oxygen, actually in peroxide H2O2, it was in -1. It was in the -1. Intermediate oxygen, actually we are telling 3 oxidation state. One will be intermediate and other two will be, one will be lower oxidation state and other will be higher oxidation state. Then an element can exist in 3 states: intermediate state, lower state or higher oxidation state. Then here in this type of reaction, reactant will be in the intermediate state. Here you can see oxygen is in -1 and products it is giving H2O plus O2. Then O2 is 0. In O2 oxidation state is 0 and in H2O oxidation state is -2. Then see, in the reactant form, means in peroxide, oxygen was -1. Now product, they given 2 product, water and oxygen. Then in oxygen it is 0, means lowest. And in H2O it is -2. Then total in the reaction 3 oxidation state is there. -1, that is in the form of reactant, and -2 and 0 in the form of product. Then this type of reaction is called disproportionation reaction. Okay. Now other example you can see. Phosphorus, sulfur and chlorine undergo disproportionation in the alkaline medium. In alkaline medium means sodium hydroxide, maybe NOH, maybe KOH, OH should be there. NOH, KOH, calcium hydroxide, magnesium hydroxide. Okay, it should be there. That is called alkaline medium. Then example I am telling you, this 3 example I will give you for phosphorus, for sulfur and chlorine. Then first to understand phosphorus, P4, Then P4, it is a solid actually. Phosphorus is solid. Okay, actually always just you can say physical status you should write. You know, when every time you make habit, then it is solid, then P4, only there in a small, you can say bracket to write S. Then P4 is zero state, zero. When it will react with, suppose it is reacting in basic medium, alkaline medium, means 3, you can write as a balanced equation, P4 plus 3OH minus, aqueous. OH minus, because why you writing like this OH minus, maybe K, maybe KOH, maybe NOH, maybe calcium hydroxide, maybe magnesium hydroxide, you don't know. But hydroxide should be there. That is the alkaline. That's why P4 plus OH minus 3OH, actually P4 plus 3OH. OH will be in the aqueous solution, AQ. Then in AQ, and this will be dissolved in water. P4 plus 3OH plus H2O. Okay, because in water you have added alkaline, you can say this thing, hydroxide, alkaline medium. You have made alkaline medium by adding OH, NOH, KOH, anything. Then this will react P4 plus 3OH minus plus 3H2O. It will react. And what will be the product? Product is interesting. Okay, should keep in mind. Then it will give two product. First product is PH3, phosphine gas. Phosphine gas, PH3. Okay, it is a dangerous gas, poisonous gas, PH3. And one gas is the phosgene gas, POCl3. Okay, that is a very, very dangerous, very, very, can say this things, poisonous gas, both. Then now you can say this PH3, it is forming PH3 plus 3H3, 3H2PO2. It is forming two products, P4 plus 3OH plus 3H2O. It is giving two products. First product is PH3. In that P has minus 3 oxidation state in PH3, and other product, that is the H2PO2, 1 minus. H2PO2, 1 minus. Then here phosphorus has plus 1 state, plus 1 state. Then see, it is giving in the product 2 oxidation states. In PH3, P is minus 3 oxidation state, and H2PO2, in H2PO2, it is P is in plus 1 oxidation state. Then this is also the example of, disproportionation reaction. Okay. Now next example you can see sulfur S8. Then here S8 is also solid, and then solid means again oxidation state will be 0. Then S8 plus 12OH minus, when both will react, means S8 plus 12OH, hydroxyl ion, means alkaline medium, then it will give 3 product. S8 is there. Then obviously it will give more product. Then S8 plus 12OH minus. Then it is giving 3 product. What are that? Then sulfur 2 minus 4H2. That is called sulfide. H2S gas is there, H2S, hydrogen sulfide. Then here you can write ionic reaction. S minus, S2 minus. First product. Second product is H2O3, sulfite, PHITE, sulfite, not sulfide, PHIDE. H2S, that is hydrogen sulfide, PHIDE. But H2O3 2 minus, sulfite, PHITE, sulfite. Plus third product is water, 6H2O. Means acid plus 12OH, it gives a balanced equation I am talking about 4S2 minus plus 2H2O3 2 minus plus 6H2O. Then here again you can see sulfur was in zero oxidation state, but in product, one product has -2 oxidation state and other product has sulfur has +2 oxidation state. Then see total 3 oxidation state always you are getting. S was in the zero oxidation state in the beginning, and after the reaction it forms sulfide 4S2 minus, that is in -2 state, and 2S2O3 2 minus. In that oxidation state of sulfur is +2. Okay. Then this is also the example of disproportionation reaction. And one more example I am telling you, that is the chlorine plus 2OH. Chlorine Cl2. Cl2 means gas, then is a oxidation state is 0. Then Cl2 plus 2OH minus, alkaline medium, when it will react, it will form ClO minus, oxychloride, ClO1 minus, and other product is chloride ion, Cl minus, and third product is water. Three product has given Cl2 plus 2OH, 2OH minus, it is giving ClO minus plus Cl minus plus H2O. Now here you can see Cl2 was in the beginning zero oxidation state, but in product, in the form of ClO, it is in +1 oxidation state, and in Cl minus obviously -1. Then here again you can see that three oxidation states are there, 0, +1 and -1 in whole reaction. Then this I told about the three reaction example I have given for the you can say disproportionation reaction. These are the very, very important, and question is asked, and it should be careful and remembering, should remember all this reaction. Okay. Then this I have told you that these reaction I am talking about, the reaction describes the formation of household bleaching agent. Last example I have given Cl2 plus 2OH, it is giving ClO1 minus, oxychloride. In that chloride has +1 oxidation state, and chloride ion -1 oxidation state. Then I am talking about this reaction. This reaction describes the formation of household bleaching agent. This reaction is also called bleaching agent, bleaching powder, bleaching powder. There this reaction will take place. Okay. Then this reaction describes the formation of household bleaching agent. The hypochlorite is ClO1 minus is also called hypochlorite, RITE. The hypochlorite ion formed in the reaction oxidizes the color bearing stains. Actually it can remove the color also. If a color is there, then it will bleach the color, means they will remove the color. Oxidizes the color bearing stains of the substances in a colorless compound. Colorless compound is there, it will give the, in that here hypochlorite ClO formed in the reaction oxidizes the color bearing stains. Color bearing the stain means it will produce color, not they will remove. It will produce color. Okay, solution was colorless, but it will give some colorful stains. Okay, this is important here. It oxidizes the color bearing stains of the substances to colorless compounds. If again here see, if compound is colorful, then it will become colorless. Okay, if due to the oxidation it happens, if substance is colorful, then it will remove the color, means it become colorless. That is called bleaching. That is called bleaching. Okay. Then it is of interest to mention here, you should know here that whereas bromine and iodine follow the same trend as exhibited by chlorine. Okay, chlorine reaction, fluorine shows deviation from the behavior. Here means chlorine and bromine, they are following the same trend, but fluorine will deviate. Fluorine is because it's a highly oxidizing agent. Okay, fluorine shows deviation from the behavior. When it reacts with alkali, it will not react with alkali. Keep in mind, fluorine does not react with alkali. Its trend is different. Okay, chlorine, bromine, they have same trend, but fluorine has different trend. The reaction that takes place in case of fluorine, if suppose if fluorine will pass in alkali medium, then what? You have seen that in case of here you have seen chlorine reacted with these things, reacted with OH. Okay, then bromine also it can react. Bromine plus OH also will react. Trend will be similar, but fluorine trend will be entirely different. Then here, if you can say fluorine will react with alkali, then it will form fluoride ion. Means 2F2 plus 2OH minus. 2F2 fluorine gas, its oxidation state is 0, you know. 2F2 plus 2OH minus, it forms fluoride 2F minus, and it will form OF2 plus H2O. OF2 here product, see, both are electronegative, oxygen and fluorine. Then here fluorine is most electronegative. Then here oxygen is also electronegative, but fluorine is more electronegative than oxygen. Then here oxygen is behaving like a cation, just like a positive, and fluorine is showing, because comparative you can tell, fluorine is more electronegative than oxygen. That's why it is making a compound OF2, oxyfluoride. OF2, because this is a rare compound, OF2. Here fluorine is taking electron from oxygen. Okay, but actually compound will be not very stable, but it is forming OF2. Both are electronegative. Like that way, other halogen compound, they themselves will react and they will form interhalogen compound. Okay, this you remember. Here it is to be noted that actually it is very important that fluorine in the reaction is undoubtedly, you can say, you should not doubt, attack water to produce some oxygen also. Here oxygen also formed, because fluorine OH will dissolve in water only, and fluorine you are passing. That's why it will react with water also, and some oxygen also it will form. This departure from the fluoride and bromide, they will not do all the things. Okay. This departure shown by fluorine is not surprising for us, as we know the limitation of fluorine, that being the most electronegative element, it cannot exhibit any positive oxidation state. Never. That fluorine never will show positive oxidation state. Okay, positive oxidation state means it will give the electron, but it is not possible for fluorine. This means that among halogens, fluorine does not show a disproportionation tendency. That is the main things here. Fluorine can't show disproportionation reaction and cannot show also. Okay, this is the important thing, that among halogens, fluorine does not show disproportionation tendency. They can't show. This question is asked. Okay, in multiple choice question also, which atom will not show, which halogen atom will not show disproportional reaction, then answer will be fluorine. Today I am stopping only here. Again we will discuss something new in the next class. Okay, thank you.